Okay, let's look at this example. We're looking for all tangent lines at the x equals 1 to the graph of this equation right here. All right, so let's do that. First thing is, since only x value is given, so we have to find the corresponding y value. Right? So plugging in x equals 1, we can get y squared minus, so this is 1, so it's going to be just y minus 6 equal to 0. Right? We can easily solve that by factoring it out. So this is going to be a quantity, say, because we have to make y squared, so it's going to be y here and a y there. All right. Then you have to get negative 6, so it's probably going to be positive 2 and a negative 3. Would that work? Alright, let's make sure. Right, 2 times negative 3 is negative 6, and 2 plus negative 3 is negative 1, so it works. So it looks like we got two y values. Y is equal to, from here, setting 2 plus x equal to 0, so it's going to be negative 2. And setting y minus 3 equal to 0, so that's going to be 3. Right there. Alright, then we need to find the slope of the tangent line. So in order to do that, we need to find dy over dx. So we need to take the derivative. Alright, so by taking a derivative with respect to x, we can get, right, so derivative of y squared would be 2y, right, by chain rule, multiply by dy over dx. Right? Right, there are two things multiplied together, so I'm going to take this guy, let's see, negative x to be the first guy, and a y to be the second guy, then use a product rule. Right? So derivative of negative x would be negative 1. Times the second, which is just y. Right, first is negative x. Right, times the derivative of y with respect to x would be dy over dx. Right, derivative of negative 6 is 0, and derivative of 0 is also 0. So I'm going to just say equals 0. Alright, then what we need to do first is that we have to combine these two terms with dy over dx in it. So I'm gonna just factor out the dy over dx since these are in common. Alright, so I'm gonna factor that out. So here, alright, just pull out the dy over dx. Alright. And from the first term, we have 2y, right? So we put 2y there, right? Then from the second term, we have negative x, so minus x. So we put minus x here, right? Then this guy, we would like to put the negative y to the other side. We can do that by adding y. So add y to both sides. So this is going to be y on the other side. So this is going to be just y. Alright. And then we can isolate dy over dx by simply dividing through by quantity 2y minus 1. Alright. So we have dy over dx is equal to, alright, so y was already there on the right, and we're dividing through by 2y minus x. Alright, so that's the derivative. Right, so let's find a couple of tangent lines. All right, so there are 2 points, 1 comma negative 2, and also 1 comma positive 3. Right, so first one, so 1. Right, we're looking at the tangent line at 1 comma negative 2. 1 comma negative 2. Right, so we have that. Then second one, say 2. Right, we need to find the tangent line at 1 comma positive 3. Right, so that's the second tangent line. Alright, so we know that, let's see, we already have a point, so we're going to call this guy x1, and this is going to be a y1. Right, so all we need to do is find the slope m. So let's find the slope m. It's going to be, alright, simply we just need to plug in, we just need to evaluate dy over dx at 1 comma negative 2. Right, so this is going to be equal to, right, y on top, so y is negative 2, so we put negative 2 there, over, right, 2 times y, so it's a 2 times negative 2, right, minus x, so minus 1, which is going to be, let's see, you have a negative 4 minus a negative 5, so negative 2 over negative 5, so negative side cancel out, so it's going to be 2/5. Alright, so the equation is going to be, using point slope form, we have y minus y1, which is negative 2, so can I write it as plus 2, is equal to, slope is 2/5 times quantity x minus x1, which is 1. Right, if you want to write it, so this is a perfectly good equation, so this is equation of the tangent line. But if you want to write it as a slope-intercept form, we can simply distribute 2/5 to both terms, so you get 2/5 x, 2/5 times negative 1 is negative 2/5. Right, then we can just get rid of plus 2 by simply subtracting 2 from both sides. So you have a y is equal to, right, so you have a 2/5 x, right, subtracting 2, so it's going to be 2 is going to be let's see, 10 over 5, so it's going to be negative 12 over 5. Alright, so if you write it in a slope-intercept form, this is the equivalent equation. Alright, so let's find the second tangent line, which is at the 1 comma 3. Right, so again, we're going to call this guy x1, so x1 is 1, and y1 is going to be 3. Right, so we find the slope. So slope is, again, formula is exactly the same, so dy over dx, but we're going to evaluate it at 1 comma 3. Right, so this is going to be, right, so y is 3, so 3 over, right, 2 times 3, so 2 times 3, minus x is 1. Right, so in this case you get the 3 over 6 minus 1, so it's going to be 3/5. Alright, so we know the equation. We can do y minus, y minus y1, which is 3, is equal to 3/5 times quantity x minus 1. All right, so this is equation in point slope form. But if you want to write it in a slope-intercept form, again, we can just distribute 3/5 to both terms. So it's going to be 3/5 x minus 3/5. Right? Then we can just get rid of -3 by adding 3 to both sides. So y is equal to, right, 3/5 x, right? So 3 is same thing as 15 over 5, so you're gonna get plus 12 over 5, right? So this is the equation of the tangent line in slope-intercept form, right? But either way, it's your preference. You can write it in either form. Right, so this is how you find the equation of a tangent lines using implicit differentiation. So we need to take the implicit differentiation to find the derivative, which allows us to find the slopes of the tangent lines. All right, that's it. I hope that this was clear.